Hello, Bhaskar this side. And as you can read the title, we are going to talk about related residual solvent and elemental impurities. Especially, we'll talk about what is the classification of residual solvent and elemental impurities, and further how to define their exposure limits. Again, there are two important ICH guidelines one has to consider while dealing with the residual solvent and elemental impurities. Q3C is especially for related, sorry, the residual solvent, and Q3D is especially for the elemental impurities. Let us now talk about the classification of residual solvent as well as elemental impurities. See, there are common points between residual solvents and elemental impurities. So I tried to give the comparison between the residual solvent and elemental impurities for easy understanding. So what is the class 1? So if you look at the class 1, as far as residual solvent is concerned, you will find that the solvents to be avoided because of their unacceptable toxicity or their deleterious environmental effect. So all these solvents will be classified as the class 1 solvents. And we all know that the benzene, carbon tetrachloride and three more solvents are the part of the class 1. So total there are five solvents comes under the class 1. If you look at the elemental impurities, again there is a class 1 elemental impurities, and the definition is this way: the elements that are human toxicants, and there are four such elements: arsenic, cadmium, mercury and lead. So the five solvents belongs to class 1 and four elemental impurities belongs to class 1. So class 2, let us talk about the residual solvents. So solvents to be limited because of their inherent toxicity. So there are some solvents which are having inherent toxicity like ACN, chlorobenzene, chloroform, methanol. So all these 31 total number of solvents are classified under class 2. Whereas the elements that are route dependent human toxicants means they can have the different toxicity based on to the route of administration, like oral versus inhalation versus injectables. Now further, the ICH guideline Q3DR2 has subdivided class 2 elemental impurities in 2A and class 2B. Let us understand the definition of class 2A elemental impurities. So the elements have relatively high probability of occurrence, means they are probably abundance in the nature. So these elements are classified under class 2A, and there are three elements mentioned into the guideline, that is cobalt, nickel and vanadium. When you look at class 2B, so these are the elements which has reduced probability of occurrence into the environment, and there are total 10 elements classified under class 2B. So this is all about class 2 as far as residual solvents as well as elemental impurities are concerned. So only difference is what? In case of elemental impurities, the class 2 has subdivided into 2A and 2B. That's it. Let us now talk about the class 3. Let us begin with the residual solvent definition. The solvents with low toxic potential, example acetic acid, isopropanol, ethanol, acetone. There are 27 solvents considered under the class 3. And what about the elemental impurities? The definition is the elements in this class have relatively low toxicities by the oral route of administration. I mean the higher permitted daily exposure, that PD is possible. I mean generally the PD is of greater than 500 micrograms per day for class 3 elemental impurities is possible for oral route of administration, but may require consideration in the risk assessment of inhalation and parenteral routes. Always remember, see, residual solvent have the common limit for oral, inhalation and parenteral route of administration. But if you look at the elemental impurities, they have the different permitted daily exposure based on to their route of administration. So you will find generally the permitted daily exposure, or it is acceptable limit for oral will be higher, then comes parenterals, and then comes the inhalation route of administration. But there could be some exceptions, one or two, but this could be the general way of defining the limits for elemental impurities. Again, as per as class 3, for elemental impurities, there are 7 elements like barium, chromium, then copper and lithium and molybdenum and lead and tin. So we understand the classification system, class 1, 2, and 3. 2 is subdivided into 2A and 2B only for elemental impurities. Okay, I hope you understand this point. Let us now try to understand how to define their limit, how to define their concentration into the drug product, maybe in terms of microgram per gram or ppm. We especially like to express the concentration in terms of ppm. So ppm is nothing but microgram per gram. So the applicant may select any of those options as long as the resulting permitted concentrations assure that the drug product does not exceed the permitted daily exposures. I will talk about this option 1, 2, and 3, especially for residual solvent and elemental impurities. You can use any one option, provided you must meet the permitted daily exposure criteria. At any given point, your PD values should not cross. That is the only requirement. Let us begin with the option 1 now. So again, this option 1 is common for residual solvent and elemental impurities. Though the guidelines are different, but as such, if you look at the content, it is almost one and the same. So you can adopt the same approach for residual solvent and elemental impurities if you are defining the limit or exposure limit according to the option 1. So what is option 1? See, the point number 1 is what? Okay, let me take the pointer now. Products that are administered in doses less than 10 grams per day should be considered under option 1. Now here don't confuse with the label claim. What they said, the product dose means entire mass of the product. Let us say you are taking a tablet of paracetamol having a mass of 100, not 100 milligram will be very low, but let us say around 800 milligram. Now in that 650 mg is the paracetamol and rest will be the excipient or the placebo. But your product mass is 800 milligrams. So if you take that tablet twice a day, what is the total consumption of the product mass now? 800 into 2 becomes 1.6 gram. So this is the way you can calculate the product mass administered daily. So this option 1 can be used in case if your administered product mass on daily basis is less than 10 gram. So this example just I have explained for paracetamol comes under the option number 1. The concentration limit in ppm is calculated by assuming a product mass of 10 gram administered daily. So in this case, what happens? You need not to actually consider the actual product mass. What you need to confirm that my product mass consumed per day is less than 10 gram. And once you do that, you can use the calculation formula for concentration. That is concentration in ppm is equal to 1000 into PDs, PD into mg divided by product mass per day, and here by default you have to consider product mass equal to 10 gram. Okay, so your product mass is fixed now, whether it is actually 1.6 gram as we explained in the earlier example, or 5 gram or 7 gram, doesn't matter. You have to consider the product mass per day is only 10 gram. Let us understand the calculation of the concentration with one example from residual solvent. And we all know the permitted daily exposure or PD value for methanol is 30 mg per day. So what is the concentration limit for methanol in the any given product according to option number 1? It is going to be 3000 ppm. I just use the same calculation formula. Let us now take the example from elemental impurities side. And let us assume the nickel is your elemental impurity, and this is the oral route of administration. The PD value for nickel for oral route is 20 micrograms per day. So what is the calculation formula going to be now? 200 microgram divided by 10. See, if the permitted daily exposure value in mg, then this 1000 is required. So you must look into the methanol calculation where 1000 is used. Why? Because the given permitted daily exposure value is in 30, is in mg, milligram. But however, in case of nickel, what is the unit of PD now? Is it mg or microgram? It is microgram. So for that, I will not use this 1000. I will only make permitted daily exposure in microgram divided by 10 gram. Just look at the unit we get, microgram per gram. So what is the another alternative way to express microgram per gram? Is nothing but ppm. So here I just use 1000 in case of methanol to convert this 30 mg into microgram. So 30 mg is equal to 30 into 1000, that is 30,000 microgram. I hope you understand. There is a slight difference between the calculations I use over here. Let us now talk about the how one can prepare the limit or express the limit for both residual solvent and elemental impurities according to option 2. See again, there is a slight difference in naming. So option 2 is for residual solvent. If you look at the ICH guideline Q3C R8, and option 2A is just similar to option 2 as like your residual solvent, but the 2A is defined for elemental impurities. Again, there is a 2B also. We'll talk about 2B very soon now. So this is the purpose of 2A now or 2. So products that are administered in doses greater than 10 grams per day should be considered under option 2 for residual solvent or option 2A for elemental impurities or elements. But principally, the procedure is one and the same. Only the naming is different, the structure is different. The concentration limit in ppm is calculated on the actual product mass. That is the difference between option 1 and 2. Actual product mass will be considered while using the option number 2. So this is the calculation formula for concentration in ppm. 1000 into PDE in milligram divided by actual product mass per day in a gram. You remember during option 1, we have considered the fixed product mass of 10 gram. But in this case, you have to consider the actual product mass. Let us take one example. So the actual product mass is how much now? 20 grams per day, okay, which is greater than 10 grams. So you have to use option number 2. So I will take the same example of methanol having PD of 30 mg per day. So I have considered actual product mass 20 grams. So I got 1500 ppm as the limit or concentration of methanol. And in case of nickel, I got now 10 ppm. I hope you understand the calculation of X limit concentrations for residual solvent and elemental impurities by using option number 1 and option number 2, and 2A is only for the elemental impurities. Let us now talk about the option number 2B. So this option 2B is only defined by elemental impurity guideline, that is Q3DR2. It is not as such defined in the residual solvent, but there is a connection between 2B and residual solvent limit expression. Let us talk about elemental impurities first. So what you have to do first, the content of elements in individual components of a product should be identified. Suppose there are three components and one API present into a drug product. So you have to identify what is the content of this impurity or elemental impurity present into each and individual component along with the API. That is the first step. And then the content of specific elements in the entire product is calculated, and then you add this content from component 1 to 3 4 and so, and then understand whether this all coming component elemental impurity is crossing the permitted daily exposure or is it within the permitted daily exposure. So this is done against the option 2B. Let us take one example to explain this option 2B, but before that I think you also must understand ICH did not mention option 2B as such, but it is used for residual solvent in case if the residual solvent content, right, in individual component is above permitted daily exposure as per option number 1. As per option number 1. See, as per option number 1 means what? By considering the mass around 10 gram, isn't it? So that is the important point. So it is also applicable for the residual solvent. Let me explain with the help of example of nickel. Oral permitted daily PD value is 200 micrograms per day. And now this is the product composition, a drug product with around how much is the weight? I think 2 gram is the weight over here of the product, but the content of API is 200 mg. The component 1 or excipient 1 is 1200 mg. Component 2 is 500 mg. Component 3 is 100 mg. So this is the composition of the drug product now. So what is the limit for nickel for API as such individually? Okay, 20 ppm. Component 1 also has the nickel with 10 ppm. Component 2 has a nickel with the 5 ppm limit, and component 3 has a nickel with the 30 ppm limit. So for using the option 2B, you also should understand whether there is a presence of the content of the elemental impurity like nickel, and what is the likely content, maybe from specification or by testing the individual component. So you can consider these values from the specification. So you understand the content of individual component including API and their limit for the nickel. Now the next point what you have to do now, you have to understand what is the content of nickel in terms of microgram from individual component and API, because 20 ppm is the concentration, but I need to understand the content in terms of microgram. So will you be able to calculate the content of nickel in API, or will you be able to calculate the content of nickel in 200 milligram API, where the limit for the API for nickel is 20 ppm? Means 1 gram of API will have how much microgram of nickel with the 20 ppm limit? 20 microgram, yes or no? So we got the first equation that 1 gram API has 20 microgram nickel. What is the content in a product? 200 mg or zero point 0.2 gram. So 0.2 gram API will have how much microgram of the nickel? So that can be calculated just by cross multiplication, and you will come to know that the 4 microgram is the content of nickel in API, 1.2 microgram is coming from component 1, 2.5 microgram comes from component 2, and 3 micrograms come from component 3. Now, once I understand the content, the next step is what? I need to add on all these values together and then come to then identify what is the total nickel content in a product. That is 10.7 micrograms now. So what is the PD value of nickel? 200 micrograms per day. But I am getting 10.7 microgram for this particular product now. And if this product is consumed daily once, I will have 10.7 microgram nickel going. It is meeting my permitted daily exposure. Even if the product is taken twice a day, it will just become 10.7 into 2. If the product is taken thrice a day, this will become 10.7 into 3, isn't it? So this is the way you can use the option 2B to evaluate the limit or concentration of elemental impurities in ppm. Let us now understand the option number third. What is the option number third? This is given for elemental impurities, and the concentration of each element may be measured in the final drug product by finished product analysis. So this is the option you can use, even though in case if there could be chance that in the during manufacturing process the elemental impurities can get reduced. So the initial content may be high, but once the product gets processed, you may have the lower content of elemental input. So to understand this, you can analyze the product and you can justify that. Look at here now, even though the initial content was little higher, but once the product gets processed, I get the elemental impurity below its permitted daily exposure by analyzing the actual finished product. See now, if you look at the residual solvent guideline Q3C R8, guideline has not mentioned like option number 3, but if you go through the guideline part you can realize that okay, now this similar option also can be used for residual solvent. In case if you do not, your product does not meet option 1 or option 2 acceptance criteria, you can analyze the product And as I explained, the content of residual solvent could be higher at the beginning of the product processing, but may get reduced because of the product processing, like temperature, vaporization, etc. And the content of residual solvent can be below permitted daily exposure. So you can analyze the product for residual solvent, and you can set the limit according to the option number 3, though it is not mentioned into the residual solvents guideline. I hope you got the better idea of classification of both residual solvent elemental impurities, and very importantly how to define their exposure limits. Thank you so much.